So we're going to apply what we learned with that discovery. We're going to put some language with it, and then we're going to practice. So what you saw, whether you know it or not, they're called arithmetic sequences. You know, not like the sequence I like to wear in my vest on weekends, okay? When I'm playing piano or like, you know, like the Dolly Parton stuff. Okay, so a sequence in which the difference between any two consecutive terms is constant. So it doesn't matter. Any two terms that are next to each other, you pick them, and it's got to have the same difference. So, for example, the ones we looked at were like 2, 4, 6, 8. Who do we appreciate? And -3, -1, 1, 3. It doesn't matter either sequence. It doesn't matter which two terms you pick. There's a common difference of 2. It doesn't matter where, right? So that's an arithmetic sequence. All right, now you might be thinking to yourself, well, what is this thing you speak of, Mr. Matt, called the common difference? Nope, I just underlined. Did I use the word common difference? No, I did not. So the difference. So we're going to be looking for a common difference, which is like summarizing that difference between consecutive things. So we can use the term common difference. And that would be the numerical difference between any two consecutive terms. And we'll say like D equals, meaning the common difference is. All right, so those are things. Arithmetic sequence, there's a bunch of different types of sequences, right? Like geometric, which I know I said right, like you would know that, but you wouldn't know that yet. You learn geometric sequences later. But arithmetic sequences, there's a bunch, so we call them arithmetic, which means they have this common difference. The common difference means the whole sequence forever is just add or subtract the same amount. Cool? Plus, you sound fancy when you use the words, right? Like, I feel like I sound fancier sometimes. I don't know. So let's just say, like, I'm gonna sling some sequences at you, and I want you to tell me, is it a sequence or not? And if it is, what is the common difference? You ready for that? So, is it a sequence or not? This sounds like a game show almost. And if it is, what is the common difference? So, first one I want to look at, 1, 5, 9, 13. So, is it an arithmetic sequence? Grin. Yep, and common difference 4. Let's check it. +4, +4, +4. Cash money. Yeah.
You just have to write 4. For example, if it was going down 4, we have to write
-4 then. Yeah, good question. I'm not gonna hit you with all these. I think you're gonna get it. What about this one? 1, 3, 5, 8. Jack?
No.
Why not?
Because from 5 to 8 is.
Yeah, so I got a 3. So there's this difference then is not common, right? Maybe someone might say it's an uncommon difference. All right, what about this one? Max, what are you thinking about this one? 5, 10, 20, 40.
I think yes.
Okay, tell me why.
Because it has the pattern of multiplying by 2.
Okay, so is that a common difference, which is what makes it an arithmetic sequence? I agree, there is a pattern times 2. So let's look at the difference between terms. You ready? Because by definition it has. So what's the difference here?
That'd be times 2.
No, that'd be 5. The difference.
Sorry, yeah.
Okay, what's the difference there?
The difference there is 10.
What's the difference here?
20.
So, is there a common difference? No, good. So, not an arithmetic sequence. It is a sequence, though. It's just not an arithmetic sequence. Good mistake. I love good mistake. Have I ever told you guys I like mistakes before?
Yeah.
Once or twice every day? Once or twice a minute every day? Okay, so let's check out this sequence. So I'm telling you this is an arithmetic sequence, okay? So, I actually changed my mind. I'm going to show you one, and I'm going to have you do that one on your own in a moment. I changed my mind. I'm allowed to do that, okay? So, here is an arithmetic sequence. Now, I'm going to want the 19th term. So, some ways you might see this is like a subscript 19 or like f of 19. These mean the same thing. I'm just going to give you exposure. What this would then say is, what is the 19th term? And so you could do like minus 4, minus 4, minus 4, minus 4. But you're probably going to miscount and get it wrong by 1. Just speaking from my personal experience taking M-steps and map tests. I've seen the scrap paper from map tests where someone did +3 like 97 times. Anybody do that? They try to keep track and like plus. I've been there. Anyway, I've got an easier way. You guys want an easier way, right?
Yeah.
Sounds like I'm about to sell you flex tape, but it's the flex tape of math, maybe. So, we can write a function for this, and then it's no big deal. Here's the function. I'm going to do a subscript 19. What's my common difference? What's happening? Remember, n is the number of the term. So first term, second term. So it's changing by -4, right? All I wrote so far, just because math is communication, all I wrote so far is for each term it's going down 4. Is that true? Okay, but my starting spot is not -4.
What is
A just is saying it's an arithmetic sequence. It's just a way. So it's the same thing as f of n. It's the same thing as f of 19. Same thing as y, kind of, if this is x, y. So 19th term. We established it's going down 4 for each term. But I need this function to pump out a 30 when I put 1 in for n, right? Because when n is 1, that's the first term. So if I currently put a 1 in for n, where am I at? I'm at -4, right? -4 times 1 is -4. I need to get that -4. This function, I need it to pump out 30, right? You guys see that? So how do I get this function to pump out a 30, Jack?
Add 34.
Add what?
34.
Well, let's check it out. Let's put a 1 in here. -4 plus 34. Is it 30? So, yeah, it looks good. When I put in a 1, it pumps out a 30. Let's test another point. Or let's test 4. If I put 4 in here, I get -16 plus 34. Is that 18? Yeah, I got a function that works. So really, big picture, my function's saying it's going down 4 each term, but I need to slide my starting spot up to 30. Right? By going up 34. Okay. Now, if I want the 19th term, check out what I can do. Oh, it's later in the day. Let's see if the mental math's all cooking. 40 and 36 is -76 plus 34 is -42. Did you guys get that too? Are you just saying yes because you don't want to have to think about it?
No, I'm just really
Okay, cool.
I did it.
Sometimes the old noggin doesn't work as good 5th hour with that stuff. Could you follow what I did there? That's called decomposition, recomposition. I'm going to give you this function. 7, not function. I mean, it kind of is. It's not a function yet. I'm giving you this arithmetic sequence. I want you to write a function for me, and I want you to give me the 27th term, please. Let's chat about this, friends. I'm going to start with just a straight-up function. What's my common difference? 6. So I got, what I wrote so far is, it says for each term it's going up by 6. That's all I wrote. That's what 6n means. Each term's going up by 6. Cool? Okay. So, it doesn't start at 6, so I need to do a little shift. So how do I get to my 7? Add 1. Now, good idea? Test it out. Slap a 3 in here. 18 plus 1 is 19. Okay, I'm good to go. Now let's do the 27, which if you have the template, I know is a little different. But I was like, well, why are we going to do 19 every time? So f of 27 is 6 times 27 plus 1. Let's go. 120 plus 42 is 162 plus 1, 163.
Yeah.
Woo! Take that, calculators. I just John Henry that junk. You have to know the story about John Henry to understand that reference. But do kids know John Henry stuff? He was the one that hit railroad ties and the steam engine came around.
Yeah.
He died at the end though, so I need to change my reference. He was racing technology.
I remember.
Well, I guess the technology won in that case, and I beat the
So in
technology.
this case, does that mean that you can say
Okay.
So that means you that
Let me give you one more. Here's your new sequence. Okay? I want you to give me a function, and then I want you to give me the 38th term. So let's rewrite that as 8 subscript 38. Give me the 38th term, please. All right. I want to get you some good time with homework, so I want this to be our last example. Help me out, friends. What's the common difference? Yeah, so negative 5n. Again, this is saying it's going down 5 each term, but I need to readjust my starting point. I'm not starting at negative 5. Where am I starting? Yeah, so how do I get from negative 5 to negative 16 max?
You subtract 11.
Minus 11. All right, so here's our function. So I'm going to slap a 38 in for n. Okay, can I do it again, guys? You think I can do this mental math again? So I got 150 and 40. So negative 190. Ooh, a 10 is 200. Negative 201. So do you guys see how... I don't know if I can explain this. But like when I do this, I imagine a 10 moving over here to be 200, and then there's 1 left over. I see numbers moving. Which made me sound a little crazier than you already thought I was, but it's true. Okay? So, as you start doing these on your own, I want you to keep those big pictures. The function just says, hey, they're changing by this much each time, and then a readjustment to where you start. Cool? All right, your homework's on Go Formative. I suggest you start at higher numbers first. And I need to open it up on Go Formative. But also, you need to keep track of where the blue dots are.